Very happy New Year 2023, dear students, and welcome in our most favorite YouTube channel, Physics Make It Simple by Dr. Rajendra Kobarne. Serving as a principal in Loknete, Dr. Bala Saheb Vikhe Patil, Padma Bhushan Awardee, Pravara Rural Education Societies, Mahatma Phule Vidyalay and Junior College, Dad Budruk Taluka, Rahata District, Ahmednagar. As long as 12 Science Wave Optics is concerned, this is the lecture number 13, and in this lecture we are going to discuss today very interesting article. What is coherent sources and what are the distinguishing features between constructive interference and destructive interference? As long as students' learnings are concerned, there are lots of doubts regarding coherent sources. How to write the actual definition of coherent sources? Many of the students are mugging the definitions again and again, and they are trying to write that definition as long as the examination point of view. What is meant by mugging? Mugging means gokampatti. Don't do gokampatti, dear students. Go up to the deep bottom of the content, so that you yourself make your physics more interesting and simplest, and so that name of our channel is Physics Make It Simple. So my humble request to all of you, at the starting of the new year, subscribe my channel, listen and observe all the videos very carefully so as to get your physics in a simplest form. Okay. Instead of chit-chatting more, we will come to our original point. What are coherent sources? Okay. Observe these two waves that I have already drawn in the last lecture. So this is a wave covering a distance x1, come up to this point. This is the another wave covering a distance x2 and reaching up to this point. Equation of this wave is y1 is equal to a1 sine omega t plus kx1. Equation of this wave is y2 is equal to a2 sine omega t plus kx2. In these two equations, by observing very carefully, what is constant, what is same? A1 and A2, these are the amplitudes different. T and T is same. X1 and X2 is different. Omega and omega is same. So concentrate the symbol omega. What is omega? Omega means angular frequency, because the formula of omega is 2 pi f. Omega is angular frequency, and so that coherent sources are those in which angular frequency remains constant with respect to time at a given place. Each and every word is important, dear student. Many of the students are writing the definition like this, whose angular frequency is constant. No, this is not a correct definition. Angular frequency of both the waves is constant with respect to time at a given place. Means this is a given place. An angular frequency of both the waves remain constant with respect to time at a given place. Angular frequency remain constant with respect to time. What is the meaning of this sentence? Angular frequency doesn't change as time goes on changing. Though time changes, angular frequency remain constant. That is most important thing. Suppose angular frequency is not remaining constant, then what happens? See here. Suppose angular frequency is not remaining constant. This is omega 1, this is omega 2. Angular frequency is not remaining constant. Then what happens? What is phase difference? This is phase, this is phase. From this phase, subtract this phase. You will get what? Phase difference. Phase difference phi is equal to what we get? Omega 2t plus kx2 minus omega 1t plus kx1. So phi is equal to, we will get what? Omega 2 minus omega 1 into t plus k into bracket x2 minus x1. So this omega 2 minus omega 1, this is the frequency difference. Angular frequency is not remaining constant, it is changing with respect to time. So angular frequency is not remaining constant, angular frequency changes with respect to time. And when angular frequency changes with respect to time, then sometimes angular frequency is greater, sometimes angular frequency is smaller, sometimes greater, sometimes smaller. Then what happens? Rapidly we get bright point, dark point, bright point, dark point at the same position. At the same position. We should get bright and dark point at different positions to get well interference pattern. And for that purpose, angular frequency remain constant with respect to time at a given place. That is most important thing, dear students. Listen carefully. So coherent sources are those whose angular frequency remain constant with respect to time. This half sentence is most important at a given place. And when angular frequency remain constant with respect to time at a given place, then we get constant phase difference at a given place. Phase difference also not depends upon time. So phase difference if omega 2 and omega 1 is equal. See here, when omega and omega is there, then what happens here? Omega, this is omega. Omega minus omega, this factor goes on cancelling, and you will simply get phi is equal to k x2 minus x1. That means phase difference only depends upon path difference. Phase difference does not depend upon angular frequency. It will depend upon path difference. As path changes, that means position of the point changes, then we get alternate bright and dark point depending upon the phase difference. That is important. At a particular single point, instantly we don't get bright dark at a particular single point here. If that point is bright, it will remain bright. If that point is dark, it will remain dark, because angular frequency is constant with respect to time. That is most important thing while learning the definition of coherent sources. Remember well, dear students. So while writing the definition of coherent sources, the first point is that coherent sources are those whose angular frequency remain constant with respect to time at a given place, whose phase difference is either constant or no phase difference. Phase difference is 0. Both the waves are in the same phase. Both the waves are in the same phase, means there is no phase difference, or phase difference is 0. These three sentences, meaning of these three sentences is same. Both the sources are having no phase difference is 0, or both the sources are having, both the waves, sorry, not sources, both the waves are emitting which are in the same phase. Or if there is any phase difference, that phase difference remain constant throughout with respect to time at a given place. That is the another condition. The third condition is that resultant amplitude. Resultant amplitude or resultant intensity remain constant with respect to time at a given place. And this is possible if and only if two sources are made up of the same and the single source. If these all 4 points are satisfied, then that sources are said to be coherent sources, dear student. Don't do mugging and mugging. Understand it clearly so that your idea should be clear at first. Then it will make more interesting and you will yourself make your physics more easy, more simplest. So what are coherent sources? I will repeat again. Coherent sources are those sources, number 1, whose angular frequency remain constant with respect to time at a given place. Number 2, which has either constant phase difference or no phase difference with respect to time at a given place. Number 3, resultant amplitude or resultant intensity remain constant with respect to time at a given place. And number 4, this is possible if and only if two sources are made up of same and the single source. These are called as coherent sources, dear student. Then we will approach the next article. What is constructive interference and destructive interference? Remember well, dear students, today's lecture is more beneficial for your competitive examination. As long as your CET examination, NEET examination, JEE examination, it will be more beneficial if you learn this today's article very clearly and sensitively. Coherent sources, after learning the definition, the concept of coherent sources, what is constructive interference? The most important thing is that interference is divided into two parts. The combination of constructive and destructive, we get interference. So constructive interference, at the time of constructive interference we get bright point that I have written at the bottom. Point is bright, we call it as constructive interference. Point is dark, we call it as destructive interference. So here I have written in a symbolic form, in a abstract form, in a short form, after studying many books, many reference books for you, and will make in a very short and correct form of a distinguish between constructive interference and destructive interference for you, dear students. So observe this very clearly. Waves are in phase. When both the waves are in phase, at that time crest meets with crest and trough meets with trough, then resultant amplitude is maximum, so resultant intensity is maximum, and we get bright point with respect to time at a given place. We call it as constructive interference. Such a huge definition I haven't written on the board. You can write yourself. Here resultant displacement is maximum, that I have already told. Resultant displacement is maximum means amplitude is maximum, and we get amplitude is equal to A1 plus A2. Resultant displacement is maximum means amplitude is maximum. You can write this 8th point here in 3rd number. Resultant amplitude is maximum, that is A max is equal to A1 plus A2. How will get it? See here. How will get it? Resultant amplitude is maximum. See here. What is amplitude? Amplitude will get is what? Resultant amplitude. Formula of resultant amplitude you have learned in the last lecture, that is root of a1 square plus a2 square plus 2 a1 a2 cos phi. When both the waves are in phase, there is no phase difference, phi is equal to 0, and if phi is equal to 0, then cos 0 is equal to 1, and you will simply get a1 square plus a2 square plus 2 a1 a2, and this is what? This is a short form of what? AR is equal to square root of a1 plus a2 bracket square, and by taking square root of this you will get what? AR is equal to a1 plus a2. That is resultant amplitude, which is maximum, a1 plus a2. Very simple. For that purpose, remember this formula that I have already told in the 12th lecture. So go back of 12th lecture, listen that lecture and come here again. Then and then only you will understand wave optics very clearly. See here. Resultant displacement is maximum, means resultant amplitude is maximum, which is a1 plus a2. And so that resultant intensity is already maximum. That is also you have learned in the last lecture, because intensity is directly proportional to square of the amplitude. If amplitude is maximum, then intensity is maximum, and you will get formula I max is equal to root of I1 plus root of I2 bracket square. That is simply here this A1, see here, resultant intensity. How that formula will come? So we can square this. AR square is equal to, by squaring both the sides, A1 square plus A2 square plus 2A1 A2 cos phi. This cos phi is 1. Cos phi is plus 1. That we have written there. So what here? AR square is equal to, what we get? AR square is equal to, instead of AR square we can write what? IR, because intensity is directly proportional to square of the amplitude. Instead of A1 we will write I1, instead of A2 we will write I2. A1 square I1, A2 square I2 plus 2 root of I1, A2 root of I2, and this is what? This is IR is equal to what we get? Root of I1 plus root of I2 bracket square. This is the square form of this. First square I1, second square I2, multiplication of 2 and twice 2 root of I1 and I2. That is a short form of this, and that is IR. IR means resultant intensity, which is maximum. I max is equal to root of I1 plus root of I2. So this third and ninth point is similar. This second and eighth point is similar. Listen carefully. Then concentrate on path difference. Path difference between two waves is integral multiple of wavelength lambda. We get constructive interference, we get bright point if path difference between two waves is, this is called as integral multiple of wavelength lambda, where n is equal to zeros 1, 2, 3 and so on. N starts from 0. This may be written as like this. Instead of n we can write 2n, instead of lambda we can write lambda by 2. This 2 and 2 get cancelled, we will again get n lambda. This is most important as long as various competitive examination point of view. So this equation and this equation is same mathematically. See here, n lambda, 2n lambda by 2. What is 2n? 2 into n is 0. 2 into 0, 0. 2 into 1, 2. 2 into 2, 4. 2 into 3, 6. 2 into 4, 8. That means you will get what? 0, 2, 4, 6. 8. That means we get even multiple of half the wavelength. So if the MCQs are asked like this, We get constructive interference if path difference is even multiple of half the wavelength, then that is also the correct result. Even multiple of half the wavelength or integral multiple of wavelength lambda. I will repeat again. Integral multiple of wavelength lambda. Path difference is either integral multiple of wavelength lambda or even multiple of half the wavelength. Then we get bright point. We call it as constructive interference. Simple. Then what is about phase difference? We know phase difference is equal to 2 pi upon lambda into path difference. That equation also you have learned in the last lecture. But more clearly, we will get some clue to write the definition, write the formula of phase difference. Phase difference is equal to n. Write down n here. Lambda corresponds to 2 pi. Lambda corresponds to 2 pi. That means length of the wave is 2 pi. What is length of the two wave? Like this. This is one wave. Up to this, here is pi and here is 2 pi. Here is pi by 2. Here is 0. 0, 1 pi by 2, 2 pi by 2. Here 3 pi by 2. Here 4 pi by 2. 4 pi by 2 means 2 pi. 2 pi minus 0. The distance is 2 pi. Angle is 2 pi. Lambda corresponds, this is lambda, length of a wave, and lambda corresponds to 2 pi. Lambda corresponds to 2 pi. So write down, on the place of lambda, write down 2 pi. And that 2 I have written here. We can write 2n pi, where n starts from 0, 1, 2, 3 and so on. Like this. We have already learned the phase difference is 0. That means phi is equal to 0. Cos 0 is equal to 1 and point is bright. That I have already explained. This is the content of constructive interference. And if we learn the concept of constructive interference, then it will make more easy to write the points of destructive interference. Destructive interference, we get dark point. So I have written here, point is dark. Waves are in out of phase. One wave is like this, another wave is like this. So crest meets with trough and trough meets with crest. Resultant amplitude is minimum. Resultant displacement is minimum. Resultant intensity is minimum, that is 0. And we get dark point. So I have written here, resultant displacement is minimum. Resultant amplitude A minimum is equal to A1 minus A2, or I minimum is equal to root of I1 minus root of I2. How we get this? See here. How we get this? So we can write AR. We can write the formula. AR is equal to A1 square plus A2 square plus 2A1 A2 cos of phi. If the two waves are out of phase, then phi is equal to 180 degree. And cos 180 degree, we get what? Cos 180. Cos 180 degree, we get minus 1. And if it is minus 1, then minus sign comes here. And we get what? AR is equal to what? A1 square plus A2 square minus 2A1 A2. Like this. Minus sign comes here and we'll get, this is completely minus 1. This factor is completely minus 1. We get minus 1. A1 square plus A2 square minus 2A1 A2. And this is the square of what? A1 minus A2 bracket square. This is AR square, sorry. AR. This is AR. This is also AR. This is also AR. And then take a square root. Then take a square root. AR is equal to A1 minus A2. By taking square root, you will get A1 minus A2. So A maximum is equal to A1 plus A2 and A minimum is equal to A1 minus A2. Cos phi is equal to plus 1. Phase difference phi is equal to 180 degree, and so that cos phi is equal to minus 1. Similarly, I max is equal to root of I1 plus root of I2 bracket square. How that come? I have already told you In similar manner, instead of plus sign, here we get minus sign. I minimum is equal to root of I1 minus root of I2 and point is dark. Only this point is remaining. Path difference is equal to 2n minus 1 lambda by 2. We should remember that formula. Path difference is equal to 2n minus 1 lambda by 2. At that time n is equal to 1, not 0. Most important thing, dear students, at the time of constructive interference, n starts from 1, 2, 3, 4. But in which time? In which case? If the formula is like this, 2n minus 1 lambda by 2. But if the path difference is 2n plus 1 lambda by 2, at that time it starts from 0. Most important thing while solving the MCQ. Either we get this condition or this condition. If this condition is there, minus condition is there, then n starts from 1. Plus condition is there, then again n starts from 0. These two formulae you should remember while learning the concept of destructive interference. So put n is equal to 1. 2 into 1, 1. 2 into 1, 2. 2 minus 1, 1 lambda by 2. Put 2 here. 2 into 2, 4. 4 minus 1, 3. 3 lambda by 2. 5 lambda by 2. 7 lambda by 2. Here also we get same. Put 0 here. We get 1 lambda by 2. Put 1 here. We get what? Put 1 here. 2 plus 1. 3 lambda by 2. Put 2 here. 5 lambda by 2. 7 lambda by 2. In both the formulae we get like this. 1 lambda by 2. 3 lambda by 2. 5 lambda by 2, 7 lambda by 2, 9 lambda by 2, 1, 3, 5, 7. Odd multiple. And this lambda by 2 is nothing but half the wavelength. If the path difference is odd multiple of half the wavelength, then point is dark and the interference is destructive interference. So, after learning path difference, phase difference, the formula of phase difference is very easy. Instead of lambda, write down 2 pi. Instead of lambda, listen carefully again. Instead of lambda, write down 2 pi. See here. Instead of lambda, write down 2 pi. 2 pi upon 2. 2 get cancelled and simply we get pi. N is equal to 1, 2, 3 if minus sign is there. Then here instead of lambda put 2 pi. So 2 get cancelled and you will get pi. If plus sign is there, then again n is equal to 0, 1, 2, 3 like this. Then put here we get again odd multiple of pi. Odd multiple of pi like this. Cos phi is equal to minus 1, A minimum is equal to A1 minus A2, I minimum is equal to root of I1 minus root of I2 bracket square. Point is dark. That is destructive interference and this is constructive interference. All the formulae is very much important as long as your CET examination, NEET examination and JEE examination point of view, dear students. And so that listen this content, listen this topic, learn this topic again and again by pausing the video, by starting the video again and again, and then we'll proceed further by taking next point till we will stop here.